All right, so we're going over the practice exam. Problem 1, f of x, y, z is 2x cosine yz minus 4z, and we want to prove Clairaut's theorem. F of xy equals f of yx. So f of x is 2 times cosine z, cosine yz. Fxx is, or fxy is, sorry, fxy is, we're gonna have, it's gonna go to the negative sign, and we're gonna be pulling out a z, so negative 2z sine of yz. So this is what we're trying to show. We do f of y, we've got the negative 2xz sine yz, and then f of yx is negative 2z sine yz, and these equal each other. Wham, bam, done. Straightforward. All right, what we got on number 2? Z is the square root of u squared plus v squared plus w squared. This can suck. And we've got u equals x e to the y, b equals y e to the x, w equals e x to the y, and we want dz dx and dz dy. And we're going to do it both methods. So recall, I'm going to write it up here, dz dx is going to be dz du dx plus dz dv dv dx.
You just put it into that
Plus dv dw dw dx.
You mentioned the color, not the space place.
I put it where it's gonna. This problem takes up more room, so I didn't want to write it where I was going to be writing. So dz du, dz dv, and dz dw all look very similar. This is something. This is smiley face to the 1/2.
Yeah.
So,
and you can erase and copy paste.
Papers essentially.
We've got 1/2, and then effectively I've got z again on bottom, don't I? dz dx.
Yeah,
equals 1/2z. And then I've got the derivative of this.
But most of the time,
with respect to u. So 2u.
That's probably
You're going to see when we do it, when we do dz dv and dz d, or when we do the dz dv and dz dw, we're going to have the same thing. So I'm going to do this. The only thing that's changing is that. Well, shit, no, that's different. 1/2z, and then I got 2u, and then I got du dx. And then I got 1/2z dv dx, or 2v. Fuck, I'm trying to erase this because I know how long the last problem takes, and I'm fucking blowing it. 2v dv dx plus 1/2z 2w dw dx. This setup right here is going to be identical for dz dy, but we're just going to replace x for y. X turns into y. That same formula though. So this is dz dx, and we're gonna start plugging shit in. Notice the 2's cancel. And I can factor a 1 over z out. I've got 1 over z du dx plus du dv or dv dx plus dw dx. Oh, I'm missing a u, v, and w. So that's dz dx. Let's plug in shit that we have. I'm going to leave the 1 over z alone. I don't think it counts with anything. X e to the y, du dx is e to the y. So I'll put another e to the y just to show where it's coming from. That's the du dx part. Plus v is y e to the x. And then dv dx is another y e to the x. And then I've got w is e to the xy, and then dw dx is y e to the x. Oops. Y e to the xy. That's the dw. So on top, I've got x e to the 2y plus y e to the 2x plus y e to the 2xy. On the bottom, I have our initial function, which is u squared. U squared is x squared e to the 2y plus v squared is y squared e to the 2x plus w squared is plus e to x, e to the 2xy. That is dz dx.
Wait, where? I got a y squared e to the 2x.
Yeah.
That's what I'm saying.
Oh, yeah, we messed up.
I got a y squared e to the 2x. I'm like very systematic.
You're right.
And
Thank you.
2's cancel and everything.
I got two. Yeah, I went too fast. Sorry. Look good so far. That's the dz dx. dz dy. I'm gonna do this. I'm gonna just rewrite this one with y's in it.
So right.
Fuck, I did it again. There's a v and a w in there.
I was able to get one.
So this time I'm going to speed up the top. I'm not going to write this step. This step is a little tedious right now. So when I do u, I've got x e to the y, and du dy is the same. I should end up with x squared e to the 2y there. And then I've got v times dv dy. I should get y e to the 2x there. And on this one, I should get, I've got e to the xy, and then the dw dy is x e to the xy. So I should have x e to the 2xy. And the denominator hasn't changed from the other one. So that's dz dy. And we start showing it the other way.
I really didn't know how to ask this question.
So the other way is to plug everything in right away.
That sounds like a pipe dream to me.
All I know is if I try to do it on one line on the test, I'm not fucking really fuck that. And you're not gonna be getting me any partial points because means that I'll have it's just one line of mistakes. One line of mistakes is better than 5 lines of mistakes. Not really, because you can get
At least you can get partial
you can
credit
get
for
partials
those.
for the 5 lines.
So dz dx should give us a, oh, I don't need to put the 1 there. I'm gonna have, it's a 1/2. I got the 2 on the bottom. x squared e to the 2y plus y squared e to the 2x.
Perfect. Yeah,
And
but
now we
with
take the derivative of the inside.
far
with respect
line, we- like easier to see where you made your mistake. Can't really read your mind when you look at one line of work. Oh, I was saying like it's not condensed. It's just like you're doing a different method.
Is there an issue?
No, I was just
Okay,
that's it.
so derivative of the inside is 2x e to the 2y plus the 2 we got a 2 come out, 2y squared e to the 2x. And then derivative with respect to x, we bring out a 2y e to the 2xy. And if we want to make it look like the other one, we cancel out 2. This, we could factor out a 2. And when we factor out the 2, it'll cancel out with the 2 on bottom. And now I've got x e to the 2y, y squared e to the 2x, y e to the 2xy. And we got the denominator, so it matches. Check. Same thing with dz dy. Bottom has the 2 and then the big square root. And then we take the derivative of the inside with respect to y. That's 2x.
Okay, so much for
Oh,
canceling.
no.
Oh, he's doing a different one. Yeah.
I was like, we went. Cancel it too. All right, I was right. So back right here. I was looking at-
And then again, can't choose cancel out.
Mr. Jones,
Yeah,
I'm pretty sure that I'm pretty sure you're supposed to find the derivative of the y squared in there. Because you're doing in terms of y in this case. Yeah.
Yeah.
That was 2y anyways. Huh?
and now that one matches.
Okay.
All right, next problem. Next problem was, God damn it. There we go. We had W equals, this is number 3. W equals sine 3x plus cosine 5y plus e to the 2z. And we got x equals t to the 7, y equals t cubed, and z equals t to the 6. And we're finding dw dt. dw dt is going to be dw dx dx dt plus dw dy dy dt plus dw dz dz dt. So derivative with respect to x is 3 cosine 3x. And then I've got dx dt. I'll do that part in red, is 7t to the 6th. And then I've got dw dy is a negative. We got a negative in there. Negative 5 sine 5y. And dy dt is 3t squared. And dw dz is 2e to the 2z. And dz dt is 6t to the 5th. So when I finish doing the substitutions, plug everything in, I got 3 times 7 is 21. I got a t to the 6th. And then I've got cosine of 3x, which is 3t to the 7th. Minus 5 times 3 is 15. T squared. Sine of 5y would be 5t cubed. And finally, we've got 12. 2 times 6 is 12. T to the 5th. E to the 2z would be e to the 2t to the 6th. Okay,
I love the street.
and that's WT. So if we do it the other way, we need to substitute everything in first. W equals sine of 3t to the 7th plus cosine of 5t cubed plus e to the 2t to the 6th. And now when we do a direct derivative, we've got cosine of 3t to the 7th times the derivative of the inside, which is 21t to the 6th, minus sine of 5t cubed times the derivative of the inside is 15t squared.
You should get the same answer, but it's kind of.
I guess it's a
And
good
then we got e 2t to the 6th times the derivative of the exponent, which is 12t to the 5th. And other than changing the way these things are written, these things are identical.
it'd be a lot.
Mr. Jones,
Yeah,
on the first part before you arrived at your answer. Oh, okay. I thought you had a Z on the outside, but I didn't realize that it was part of what you were defining the X, Y, and Z. What they were equal
oh,
to.
sorry, yeah.
No, that was my bad. I was just I thought they were together, but yeah.
I had
that was
part
my
of the thing off the screen and that was a problem.
Yeah.
It was my fault.
It doesn't look like that.
Thank you.
I've been studying the earlier years. They're probably harder. The beginning ones are like, oh, I mean, you use all that.
You guys ready for number 4? Number 4, we got x squared z squared minus 2xyz plus y squared z cubed equals 13. And we want to use implicit differentiation to find dz dx and dz dy. So what we're going to do is we do d dx of that whole equation to find the dz dx. So, and we're assuming z is a function of x. So that needs to get hit, that needs to get hit, those need to get hit, and that needs to get hit. So we got a product rule in the first one. We've got 2x z squared plus 2x squared z dz dx. And then I've got minus 2yz minus 2xy dz dx. And then I've got plus 3y squared z squared dz dx equals 0. This term has a dz dx, this term has a dz dx, this term has a dz dx. So I got dz dx equal or times 2x squared z minus 2xy plus 3y squared z squared. And then the other terms, I'm going to subtract over to the other side. So I'll get a positive 2yz over there and a negative 2xz squared. So we seal the deal by dividing. dz dx equals 2yz minus 2xz squared over 2x squared z minus 2xy plus 3y squared z squared. If you want to check your work, this should be equal to negative df dx over df dz. And you'll see that it does. Then when we want to do dy, Start over, back over from the beginning. Got x squared z squared minus 2xyz plus y squared z cubed equals d dy 13. The things that need to get hit here is z, y, and z, and then y and z. So we got a couple product rules in there. I've got 2x squared z dz dy minus 2xz minus 2xy dz dy plus 2y cubed plus 3y squared z squared dz dy equals 0. Again, I'm going to highlight my terms that have dz dy and we'll factor that out. And then the other terms, I'm going to move to the other side. Positive 2xz minus 2yz cubed. And we seal it, finish it off by getting rid of dz dy's coefficient through division. And this should equal negative df dy over df dz. And you can verify that and check it. So you have a check.
He said DFDV and then put DFDX.
Oh, yeah, you put df dx instead of df dz. Oh, I see it, yeah.
You guys ready for number 5?
Thank you.
Okay.
What's the line?
Jones on turbo.
I'm trying to do not only do the test, but slow down and explain what I'm doing in 50 minutes. And I know how long number 7 is. That's the problem.
Yeah.
I have it flipped. I have all the signs flipped. Does that end up with the same answer? Like you see every single sign flip? Every sign flip? Yeah. Every sign's flipped?
Oh, I made signs about, all right.
Yeah, I guess every single sign is flipped, then it's like basically
The same thing.
same thing, except you multiply the top bottom by -1.
By -1 and you'll get the same answer.
How my business answers are coming up.
If every single sign is flipped.
How did you get your signs flipped? That like you would have had to introduce a negative throughout the whole thing. Number 5, we have f of xy is 2xy minus x squared y squared.
Other side, they became negative.
P is 3, 5. U is listed as negative 5, 4.
I can give you. I think it
And we
depends
want
on
the
which-
rate of change of f and in the direction of u.
I believe that it's doing that. I'm pretty sure
they're-
that is the same answer.
They're equivalent, yeah.
Yeah, they should still be equivalent. Yeah.
Probably.
Yeah, so all you did was instead of moving the non-dxdz's onto the other side, he moved the dxdz's to the other side. So that's why he had offset signs.
That makes sense.
Yeah, what a terrorist.
Okay, so we do this with respect to y or x. You've got 2y minus 2xy minus 2xy squared. And then with respect to y, this is a vector. Gradients make vector. I've got 2x minus 2x squared y. That's the gradient f.
That's good, yeah.
So the gradient of f at p,
I got stuck when I said which direction of the greatest rate of change.
we're plugging in 3 and 5. I got 2 times 5.
Which way?
I'm just plugging in the values. And when we work that all out, we get negative 140 and negative 84. So that direction, answering the last question first, this is the direction of the greatest rate of change.
So like, say if we had that in there, but we just didn't like make that little note, would you still accept it?
Well, you need to answer the question.
But that's the answer right there.
So just write greatest rate.
It's
You
interpreted
need
wrong.
this as part of doing the other steps. So no, that is not acknowledging it. No one gets free points by accidentally skipping something. Now, when we do gradient of f dotted with u needs to be a unit vector, and right now it's not. So let's make u a unit vector. We got negative 5, 4, and we need to divide that by its magnitude, which would be negative 5 squared or negative 5 squared plus 4 squared. So u as a unit vector is, I'll put a hat on it.
No.
We got negative 5, 25 plus 16 is 41.
Oh, you mean like the rest?
So when we do gradient of f dotted with u, we got negative 140, negative 84, dotted with negative 5 root 41 over 40 root 41, 4 over root 41.
It's not bullshit. If we gave it to that, I thought it was already a.
Dot
No,
products,
no.
these get multiplied and these get multiplied.
I know, but usually,
Not all the time. There will be some
like
times where.
in the textbook, can you like make an A instead so we know it's not a unit vector? That's what they did in the textbook. In the textbook, it would have like the A vector. It wouldn't have U.
No,
But when you see U, I automatically thought it was already a unit vector.
If you, no, I'm not going to do that. I want you to use your brain. If you can't identify that that doesn't have a magnitude of 1 on inspection, just negative 5, 4, if you don't see that that would have a magnitude of non-1, you're not thinking. So I want you to think.
How do you see
Problems
that?
don't hand themselves to you like A and U in real life. So I expect you to think. And this ends up being, we got, if I factor out the 1 over root 41, I've got 700 minus 336.
Yourself a program that will turn all your vectors to unit.
Other way up, that'll help one. This the greater than less than. That's a-
If it helps, you can just divide by the magnitude of U at the end.
Well, what does U really stand for, if not unit vector? Your mother.
It's just some vector U. I think it's the hat really identifies.
Mr.
as a
Jones?
unit vector, but you can
Yeah.
write it out.
Are you okay with us leaving square roots in the denominator for the test?
Yep.
All right.
But it should be condensed down to one thing like this.
Wait, why when you did the dot product, you don't have a vector not attached?
He did do the dot, or what do you guys do?
Like in that, so when he writes dot, U.
So there's the whole problem. Get it all on the screen at once.
Wait, what do you mean? He did do the dot product though.
That product's right here.
Yeah, I'm saying with the notation
Up here?
left,
Oh, here.
like that shouldn't that have a little?
Oh. Yeah, I guess you could say that. Talking about when you define that the gradient of f should be dotted with U. And it should be dotted with the, not the actual dot product that you did. It's just, yeah.
Is that what you want? Is that what the complaint is?
Yeah.
Okay. All good? Oh wait, I gotta check chat. I see it pop up. All right. All right, number 6.
Hey, yo, Joe.
What? All right, we're doing number 6.
Oh, did I get up? Sorry, Lawrence, I didn't get it.
I'll scan this and upload them. So we want to find the tangent plane to x squared plus 4y squared plus 4z squared equals 9 at p is -1, 1, -1 by using the gradient. So we need, if we call this f, f of x, y, z is x squared plus 4y squared plus 4z squared minus 9. The gradient of f, you don't really need to write this line right here, but I'm reminding you what I'm doing. Is 2x plus 8y, not plus, comma 8y, comma 8z. So that's the gradient of f. The gradient of f at p, -1, 1, and -1 is 2 times -1, comma 8 times 1, comma 8 times -1. This is -2, 8, -8. So the tangent plane, we will use those for coefficients. The tangent plane is, just as a reminder, the general formula, we got the gradient of f dotted with r prime, which is this df dx, df dy, df dz, dotted with x minus x naught, y minus y naught, z minus z naught. And that equals 0. That's the tangent plane. In this case, that is -2 times x minus -1 plus 8 times y minus 1 minus 8 times z minus -1. So I've got -2x minus 2 plus 8y minus 8 minus 8z. These are becoming pluses. Minus 8 equals 0. Moving the constants to the other side. -2, -8, -8 is -18, so it comes +18 over there. That would work. I'm going to divide by -2. Either one of these. I think this is the cleaner looking one.
But you know, if you don't trust yourself to be able to divide by -2. You know how you guys are with your negatives after all.
I made them all X's and then negative. Yo, fine. I had X equal to some number is the plane. And can you take my test for me? This is a roller coaster.
All right, 15 minutes.
Right, let's get number 7 going. Yeah, 15 minutes. You believe in
Let's get it.
11.
I can do it.
Number 7.
Number 7, f of xy equals x cubed minus 3x minus y cubed plus 12y. And we've got a quadrilateral with vertices. I'm going to draw it. We got -2, 3. Let's draw some pictures. -2, 3 is up here. 2, 3 is up here. -2 is right here. And 2, 2 is right there. So it's not a rectangle. So I'll call that side A, B, C, and D. First thing we're going to do is identify local mins and maxes. So local mins and maxes will occur where f of x and f of y equals 0, not f of x, partial of f with respect to x equals 0, and partial of f with respect to y equals 0. The partial of f with respect to x is 3x squared minus 3. This gets us 3 equals 3x squared. X squared equals 1. So x equals plus or minus 1. We do the same thing over here. The derivative here is -3y squared plus 12. If I could move the 3y squared over to the other side, y squared equals 4. So y equals plus or minus 2. So we've got 1, 1. Not 1, 1, 1, 2. 1, -2. -1, 2. And -1, -2. Those will be either saddle points, local maxes, or local mins. Let's figure out which. So fxx is 6x. fxy or fyy is 6y, -6y. So D, and what is f of xy? F of xy is 0. So D is just going to be -36xy. So if I plug in two positive numbers, this is going to be less than 0. That's going to be less than 0. And I plug in two negative numbers, that'll be less than 0. The two ones where I've got a negative, only one negative sign in there, will cancel that negative sign. D will be positive. These will be greater than 0. So 1, 2, and -1, -2, these are saddle points. For the two that are greater than 0, we got to check f of xx. If I plug in 1, I get 6, which means this one has concave up, which means this is local min. And this one I stick in -1, I get -6, which means it's concave down, local max.
Hey, Mr. Jones,
Yeah,
-1, -2, is that even on the plane that we have set out?
that's an excellent question. It's not, is it?
No, it doesn't look like it.
Fuck. Still got an error in there. Thanks a lot, Brandon. Where were you like on Saturday?
One
-1, -2 is outside the grid.
One -2 isn't in the grid either.
Wait, 1 negative?
One -2 as well, Mr. Jones.
Oh, you're right. Yeah, 1 -2 as well.
Damn it. So apparently there was a lot less extrema than I thought. We got a saddle and a local max in that range. All right, so what about absolute maxes and absolute mins? We got to check along the edges. So along A, y equals x. You can you can find the slope. You can do the long way of finding it. You'll see that that's y equals x. So that changed f of xy into just a function of x. I've got x cubed minus 3x minus x cubed plus 12x. So f of x is just 9x. And when we take the partial with respect to x, this is 9, which does not equal 0 anywhere, so only endpoints.
Oh, they're both, my bad, then there's multiple. We made critical mistakes.
We go along B. Along B, what remains constant is x equals 2. So f of 2y is 8 minus 6 minus y cubed plus 12y. What really matters is f of y at this point. Negative 3y squared plus 12. We saw this earlier. This is plus or minus 2. So if 2, 2 or 2, negative 2 is on the grid, we need them. 2, 2 is one of our points, actually. It's that one. And 2, negative 2 is not. So we don't need that one. If we look at C, along C, y equals 3. We've got x cubed minus 3x minus 27 plus 36. When we do f of y or f of x here, this is 3x squared minus 3. Again, we need x equals plus or minus 1. And that goes with 3. So 1, 3 or 1, negative 1, 3. 1, 3 is on the line. Negative 1, 3 is on the line. Those are both valid points. So right now we got 1, 2, 3, 4, 5 to check. Plus the corners if they're not already listed. And along D, we have x equals negative 2. We're focusing on the y portion. Again, this is when we do f of y, we're back to negative 3y squared plus 12. So y equals plus or minus 2. So we're looking at negative 2, and negative 2, positive 2. Negative 2 is one of the points. Negative 2, positive 2 is right there. So those are both valid.
Yeah, it's the creation of that weird, the line of part of the rectangle.
So what points do we have? We've got, let me make a little table here. My XY is, I've got 1, 2, and negative 1, 2 from our maxes in Saddle Point. Saddle Point clearly isn't going to be a absolute min, right? That one's off the list already. Because it's a saddle.
Actually, all these are in range, obviously. These have to be in range. That's
Then we got our other ones. We've got 2, 2. We've got 1, 3, and negative 1, 3.
Oh, Benjamin.
Negative 2, and negative 2, positive 2.
Oh, choice.
Am I missing any points on the corner points? We had 2, 2 is a corner point. This is one of the corners. That's the, or vertices is a better way to call it. That's a vertice. That's a vertice. I'm missing negative 2, 3 and positive 2, 3. So I'm going to plug these into f of x, y. And I'll put some lines in here to make it a little bit easier to read. I'm going to do all the x cubes first. This would be negative 1. This would be 8. That's 1. That's negative 1, negative 8, negative 8, negative 8, and 8. That's my x cubes. When I do my minus 3x, this is plus 3, minus 6, minus 3, plus 3, plus 6, plus 6, plus 6, minus 6. Minus y cubed. The ones that have a 2 in them will be minus 8. The ones that have a 3 will be minus 27. And -2 cubed is -8, and we make it negative is +8. And then 12 times y, 12 times 2 is 36.
Wait, no. 12 times 2 is not 36.
24. Just testing you. 12 times 3 is 36.
There you go.
And then I got -24 here on that.
Yep.
All right, what do we get when we add all this shit up? 27 minus 9 is 18. These 8s cancel. 24 minus 6 is 18. 36 minus 30 is 6, plus 1 is 7. 39 minus 28 is 11. Those cancel. 6 minus 24 is -18. -16 plus 6 is -10, plus 24 is 14. 36 minus 27 is 9 on both of these. This is 9 minus 2 is 7. 9 plus 2 is 11.
Find and label it.
So the absolute maxes are here and here.
I can start writing. Let's go.
-18.
And our absolute min is -18.
I have did it for the last problem.
And bam, done.
Wait, 4 minutes to spare.
With
You
4
might-
minutes to spare.
Now that you're done, you want to change that plus 11 to an equals 11 at the bottom?
Oh my goodness.
You want us to label the points that absolute max they're at, or do you want us to just say their value?
This, if you do it like this, something like this, it does both. The absolute max is 18 and it's at these points. The absolute min is -18 and it's at that point.
We don't need a mark on settle.
Well, no, because the
What?
saddle point would be an absolute max or an absolute min.
The
It
saddle
could never
point
be-
cannot be either, because in one side it's got a negative slope, and the other direction it's got a positive slope. Something's got a point below it and a point above it by definition on the saddle point.
It's like the 3D version of an inflection point.
You only said.
So you
It's
would
like,
never-
it's like the
never,
3D version of,
calculate that, Eric.
like a saddle
You
point
would never
on,
calculate that, because the saddle point would never be able to be an absolute max point or absolute min point.
No, I mean,
that's a critical point, but that's a saddle point in 1D.
It's, and maybe label the critical points.
Inflection point.
so I don't know.
I was.
Ryan over here, like,
I was thinking about everything and I thought of,
Remember the input, the boundaries,
Well, I know on the test, I'm gonna be feeling like a whole time.
I can guarantee you.
There are a lot less points to check on the test.
I'll think.
I'll holding my SI hours as usual tomorrow. SI hours will change next week. I will not be here on Monday, so there's gonna be none on Monday.
Lawrence, are you coming both days?
Yeah.
All right, I'll just be there.
Me too.
If you're coming, message, don't yell it over here. Message me on Discord or something like that. That way, if like 10 people message me, I know I need to grab a big table if I can.
But you will get. But I'm just saying, it's gonna want all the stuff. Yeah, even if you just have like a square on the outside or something, you don't. Okay, that's it for me. Good luck on your test, guys. Let's see tomorrow. All right, I guess I'll see you Tuesday then.
Yep, have a fun wedding.